Okay, so this right here is something we went over yesterday, but I want to go over it again. What we're doing here is we're starting with a general power function, which is a constant times x to a power. What's being applied right here? What's being applied right here? The something definition of... This is the something definition of something. What is that right there? Limit definition of... Limit definition of... Limit definition of... Derivative. Yes, that is the limit definition of derivative right there. Limit definition of derivative. Limit as x goes to a, the derivative at f at x equals a. At x equals a. So we do this out. You end up here. Why can you pull the c out to the outside? Why can the c go to the outside of the limit right there? Why is that allowed? What value is changing in the limit? X is changing. Does C contain anything with respect to X? No. So you can pull it out to the outside. C is independent of X. Okay, so you're stuck with this thing right here. So what do you have to do? Do you remember what we did at this point yesterday? We did something to the numerator. What did we do? We factored it. We factored it. And we factored it into this thing right here, where you can pull out an x minus a, which is the magical thing, because once you pull out the x minus a, what can you do with those two x minus a's? You can cancel them, and you're left with this very useful thing right here. It looked kind of nasty. What's going on? X now is going to a. X is going to a. So what can you now replace? A can now equal... X is going to a, so x can be replaced with a. So each of these terms, this is a to the n minus 1. This becomes a to the n minus 2. This becomes a. Each individual one of these terms becomes a to the n minus 1. Because what is a... Sorry, excuse me. What is a to the n minus 1 times n minus 2 times a to the first? What does that equal? A to the n minus 2 plus 1, which is a to the... All of those terms become a to the n minus 1. And how many of them are there? How many of these things are there? There's n of them. So if you have n of them, instead of doing plus, adding it together n times, you can just say n times it. You can just do n times that. So what does this now mean? It means that if f of x is equal to cx to the n, then f prime of x is equal to cnx to the what power? To the n minus 1. So we did a few of these before. These are our first derivative rule. Yep.
So how do you factor out, like, what are the steps for factoring out the x minus a from x?
You can now differentiate any what? Any what? Polynomial. Because a polynomial is just a group of these power terms. That's it. So let's say capital of h of x was equal to 2x cubed minus 5x squared plus 8x plus 9. Can someone tell me what h prime of x is equal to? Plus 0. Yeah. Is this a little faster than the limit definition? Yeah, this is a little faster than the limit definition. Is this method only applicable to polynomials?
No.
Pretty much. Are there lots of other functions that this method doesn't work on? Yes. Keep in mind this is only differentiating things that are x to the n. This is the only form that this applies to right now. C times x to the n. Here's a function it doesn't work on. Let's say I gave you j of x was equal to 7 to the x. Can you tell me anything about the derivative of that yet? No. Some people are going to fly through the, oh, the derivative is j prime of x is equal to x 7 to the x minus 1. No. No, 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 no. Don't do that. So right now you can only differentiate polynomials. Only polynomials right now. You can make it. It works on something better than polynomials because you could theoretically have j of x is equal to x to the 3/2. Is that a polynomial? No, fractional power. Not allowed to have fractional powers in polynomials. Oh, excuse me. You can't have fractional powers. I mean something like this, like x to the. What's the? You know what? Wow, I am getting confused now. What are the restrictions on powers in polynomials? Can this be a term in a polynomial? That's my question right now. We'll pause for a sec. The derivative separately. Yeah, that's why you can differentiate any polynomial now. You have lots of different terms. Adding and subtracting is fine. The difference rule, same thing. Same exact thing. I like how they say things are rules. So this is great. Yay, awesome. But what does it still not help us answer? B to the x. Like more generally speaking, what happens if I gave you like j to the x is equal to 7 to the x? You now know that j prime of x is going to be 7 to the x times something. 7 to the x times something. Now you could flounder around polynomial. No, x can't be in a power for it to be a polynomial. But can you find the derivative of this? Yeah. Who wants to tell me the derivative? Lily, tell me the derivative. What is it? What's the derivative of that? What do you do with the 3, the power? Yes, so what does the coefficient become? No, what's already there? So what's 3 times 2? 6x, and what do you do to the power? What do you do to the power? The power was 3, what do you do to it? Do you remember the rule we just did?
Yeah.
F of x is equal to cx to the n. F prime of x is equal to c times n x to the n minus 1. So what does the power become? Yep. And what's the derivative of e to the x? We just did it. What is the derivative of e to the x? No. We literally just did it. What is the derivative of e to the x? Yeah. So the derivative of this is 6x squared minus e to the x. Because we used, what rule did we use right here? The power rule. And this rule right here we just used, I don't think I have a name for it. It's not a log. You don't call it log rule. You're differentiating power function. It's not a power function. It's an exponential function. I don't have a name for it, surprisingly, which is very strange. I'm not sure.
Make one up.
Let's make one up. Well, I guess that's a bad question. If I were to multiply two functions together, the proper derivative is this. Are you allowed to do the derivatives separately and then multiply them together, is my question. No. You can't do derivatives separately and then multiply them together. That's not good. You can't do that. Product rule. If you are taking the derivative of two functions multiplied together, what do you see here? F multiplied by g prime and g multiplied by f prime. This is super easy to remember. It's f multiplied by g prime and g multiplied by f prime. Can you switch the order of those two big terms right there if you wanted to? Yeah, addition is commutative. You can do it in either order. So let's look at this again. Let's say we had, what was it, x squared times 3x. What's the first function? X squared times 3 plus 3x times 2x. This is 3x squared and 6x squared, which is that the proper answer? That is the proper answer. Yay! Woohoo! Very cool. Now that right there, it doesn't seem necessary on that one because can you simplify the original product really easily? Yeah, the original product can be simplified really easily. But what about something where you can't simplify it? Let's say we had e to the x times x squared. Is there any easy way to combine those terms? No, there is no way to combine those. What's the derivative of e to the x? What's e to the x? So actually, the derivative of the first times the second plus the first times the derivative of the second. 2x. What can you factor out of both of those? You can factor out e to the x times x, right? So what do you end up with? X plus 2. It's just one way to simplify it. Yay! We now can differentiate more stuff. Wonderful. Is this a lot easier than using the limit definition? Are you still going to have to use the limit definition sometimes? If you absolutely can't, no. If you absolutely cannot, if you don't have a rule, what's your fallback plan? It's like the quadratic equation. What's your fallback plan? Limit definition of derivative. Limit definition of derivative. Limit definition of derivative. What's it equal? The derivative of the first times the second plus the first times the derivative of the second. Can you simplify that a little bit? E to the x times what, 1 plus x? Yeah, you'll see it like that. What about this one? The derivative of the first. What's the derivative of the square root of t?
1/2
T to the, yep, times 1 minus t, plus the first times the, what's the derivative of 1 minus t? Yep. And you can definitely clean that up if you want, but I'll leave it like that. Are we okay so far?
Could
Yeah.
you put, like, distribute this?
Yes, you could distribute first and not use this. Yes.
And you get the...
You get the same answer. It might be in a different form. It might look really weird in comparison, but they will be the same, yes. If f of x is equal to g of x times root x, where g of 4 is 2 and g prime of 4 is 3, find f prime of 4. So if you're going to find f prime of 4, what do you need to find first? F prime of... If you're going to find the derivative evaluated at 4, what do you need to find first? The derivative. If you're going to find the derivative of f evaluated at 4, what should you try to find first? Find the derivative, or some form of it. So what's f prime of x going to be equal to? G prime of x root x plus g of x 1/2 x to the... so what's f prime of 4 going to be? G prime of 4 times the square root of plus g of 4 times 1/2 4 to the negative 1/2. What's g prime of 4? They tell you that. It's 3. What's the square root of 4? What's g of 4? And what's 1/2? What's 4 to the negative 1/2? 4 to the negative 1/2. 1 over the square root of 4. So you end up with 6 plus 1/2. So it's going to be equal to 13 over 2. That's just fill in the blank right there. You can do lots of powerful things now. You can do lots of powerful things. Do I want you to? No. Find an equation of the tangent line to that curve at that point. So if you have a point, what's the only other thing you need in order to write the equation of a line? What? You need the slope. So we need the derivative first. Y prime is going to be low d high minus, that's fine, high. What's d low? All over. And we want the derivative when x is equal to what? 1. What do you end up with on top? So y prime when it's equal to 1, what do you end up with? Well, you end up with, hold on, 2e to the x minus 2e to the x all over 4, which is 0 over 4. So what's the equation of the line? Y equals? Because what is it? What kind of line is that? It's a tangent line, but what type of line is that? Horizontal. It's a horizontal line. Okay, the third one. Quotient rule? Who wants to tell me what f prime is? Biggie, can you tell me what it is? Low, what's the low function?
X.
Yep, what's the high function? Oh, sorry, low d high. What's the derivative of the high function?
6x
Plus 2 times
times 1/2
x to the...
negative 1.
Yep. There it is. That's part of it, right? I'm good with that. Good. So that's low d high minus high. What's the derivative of the bottom? What's the derivative of x? 1. All over what? Yeah. Can you clean that up?
Yeah.
Sure. There's a faster way to do this third one. What is it? There's a faster way. What can you do to that first? Not factor. You can simplify first. Do we have to use the quotient rule at all on this one? No. Just because you see a quotient doesn't necessarily mean you have to use the quotient rule. If you see a quotient, what should you always try to do first? Well, no. If limit definition is your fail-safe. But if you see a quotient, you should think, can I simplify this to make it not a quotient? Okay? Can you simplify this one? Yeah, what's 3x squared over x? 3x. What's 2 root x over x? 2 to the? Yeah. So what's f prime of x equal to? 3 minus x to the negative 3/2. I simplified that. I dropped the negative 1/2 to the front. Is this a little bit simpler than what we just wrote up here? Yeah. Do you have faith that these are the same? Yeah, they should be the same, but do they look the same right now? No. You'd start simplifying it. When you get a really simplified answer, it probably means there was a quicker way. Probably means there was a quicker way.